Hey everybody, Chris Masto here. I haven't put up a video in a while, so I figured I would just do this one real time, one take. It's going to have a bunch of mistakes. It's going to have me sipping my seltzer here, so that hopefully my voice will hold out. And I just want to do kind of another Fusion 360 start to finish tutorial. So the idea here was inspired by a post on the Glowforge forum, which was itself inspired by this lamp. Someone had asked how you would make something like this. So looking at this, obviously a prime candidate for making something with a laser cutter. Looks to me like there's just a couple discs on the top and bottom with probably slots in them, and then these fins which fit into the slots, and you glue them in and you're good to go. So let's see how I might go about replicating something like this. There are obviously a lot of different techniques, a lot of different ways you could do these kind of things, and my way is not necessarily the right way. You know, this is so simple that you could really just go into Inkscape or Illustrator and you could just draw out one of these fins. In this case, it looks like there are 16 of these, so you could just make the slots in it and you'd probably be good. But I like to do these things in 3D because it's more fun. It's also the way I think. What I like to do when I see this is actually start with kind of the thing I'm fixturing it around. The lamp has to fit over a light bulb, so it'd be nice if we had the light bulb and possibly even one of these hanging cords. So I looked up just hanging lamp cord. There's tons and tons of them around. So you could imagine that top disc is going to fit around this flange here on the cord. I'm not going to model the cord because that's get kind of complicated, but if I were going to make one of these, I would buy one of these cords first and I would measure it and I'd figure out exactly what the spacing has to be and everything. So we'll just kind of skip over that part. But I do want to use the light bulb as kind of an anchor point. One thing I found really helpful when I want to do things like that is to go to a site like GrabCAD. There are others as well, where people share 3D models for stuff they've made. And it's surprising what you can find. So if I just search here for light bulb, you know, there's tons and tons of light bulbs that people have made. I kind of like this one here. It's got that weird vintage filament thing going on. So I need a light bulb, and someone has gone ahead here and they've designed and shared a light bulb. So how convenient. So what we can do is sign up for an account, and you can just download the file and import that into Fusion 360. Now, I've gone ahead and done that to save the trouble. So I have over here in my data panel the amusingly named Bong Den file, but that's the light bulb right from here. We can open that up. Now, even though this is a SolidWorks file, you see on here it's got a SLDPRT extension. Fusion 360 is compatible with a lot of different CAD formats, so it has no trouble with that at all. So here's my empty file. We'll go ahead and try to stop saying go ahead. And what you can do is you can insert this into your current design. Ooh, you got to save the file first. So as like I said, I'm going to make a bunch of mistakes along the way. So let's just call this Pendant lamp. Okay, now that that is saved, I can insert the light bulb here. Now, it might not be incredibly obvious at first that this light bulb is a bit large, but that aside, let's go ahead. I said go ahead and count the number of times I do that. How big is this light bulb? I don't have a scale reference, so I'll click measure and I'll just measure this sort of outside diameter here. It's a 13-inch diameter light bulb. So clearly this is not to scale, or something has gone wrong, but that's okay. What's kind of cool is we can fix that. We can go back to the original file here that we imported, because the Fusion 360 links things together when you do that, right? So if I make a change in the original, it'll actually propagate through to my design. And now what I can do here is I can inspect this sort of ring around the base here and see that this is 138 millimeters in diameter. Now, this style of light bulb, and certainly if we look back at our hanging cord here, you might see it says E26. E26 is pretty much the standard light bulb base in, at least in North America. What that means is it's a 26 millimeter diameter. So the fact that this is 138 millimeters clearly means that this is not the right scale. But it also makes it really easy for us to figure out how to scale it down, right? Because that was, I've already forgotten, that was 138, and we want it to be 26, right? So we can sort of just trivially select this, and we can scale it, modify scale, and the scale factor would be, we want it to be 26 out of 138. Right? Let Fusion do the math. There we go. So now if we go back and measure this part, that's going to be exactly 26 millimeters in diameter. So cool. So now when I save this and we go back to our pendant lamp project, there's a bunch of places where we have a little exclamation mark with a link telling us this component is out of date. So this is linked to something, and the thing that it's linked to has been updated. So we can click Get All Latest, and it will now go ahead and update that from the linked file. So cool. So we've now got our E26 base. Or we've got our E26 light bulb, which means in theory the whole rest of the light bulb is to reasonable scale. Now what I like to do as well is this is sitting in kind of a weird spot, and I would personally prefer to have this bulb kind of in a logical place relative to my workspace origin, which is all the way over here, this thing. So I'm gonna move this by selecting Move, and I want to move the whole component. Doesn't matter. And there are different types of move things you can do here, right? You can drag it around and stuff. But the first thing I think I'll do is pretty obviously. Sorry, I don't like the way this was selected. There we go. I don't know what kind of axis that was selected on, so I deselected it over here, and then I clicked over there instead of having clicked on some random part. And the reason for that is because I wanted to grab this little handle here and just turn it 90 degrees. So that's the orientation it's going to be in the lamp, and so that's the orientation I want. Now the other thing, whoops, it's easy to accidentally press too hard and do something weird. So you can see here if I sort of rotate my view that this lamp is kind of sitting in the middle of the ground, and what I would really like it to be is just sitting right on this origin spot. So there's an easy way to do that. You can do a point-to-point move, they call it, and I can select a point. Conveniently, there's a point right here on the very tippy tip of what's now the bottom of the light bulb, and I can say I want that point to be lined up with that point. And boom, now our bulb is sitting nicely in the middle of our workspace at exactly the 0, 0 position. And that makes me happy. So I'm going to just save that here. Next step here is to start designing the lamp around the bulb. I'm going to do that. Again, there's a lot of different ways you could do it. Where do we start? I can close this side panel. I don't need that anymore. Usually start by creating a sketch. And in this case, what orientation do we want the sketch, right? If I hide this, right, we can be creating a sketch on the ground. We could be creating a sketch sticking up in the air. Well, in this case, I definitely want, you think about it like as this bulb is sitting there, right? I want to create a sketch on this plane because I want to start designing the fins that wrap around the lamp. So that makes sense to me. So we'll do that. Whoops. Yeah, capture position of the, I should have done it before. When you move something, you're going to capture the position. So that's where it sits now. Okay, so we're now looking edge on to the bulb, which is perfect. And we can start thinking about how we're going to draw. Again, if you imagine sort of your 2D view of the world, if you're looking straight edge on to this lamp, what would you see, right? You would see a disc on the bottom, but that disc would look like a rectangle, and same on the top, and then the fin, you could have one fin coming out like that, right? So that's basically what I'm going to draw. I'm going to draw the top piece, the bottom piece, and one fin, and then we'll duplicate that fin 16 times, and we'll be good to go. So let's start with just a rectangle. So I'm going to press R. Now what I'm going to do, and this hopefully will make sense in a moment, is just draw a rectangle like this. One of the tricks, if you're kind of new to Fusion 360 and presumably other similar CAD programs, is to get used to drawing things and then dimensioning them and aligning them, and setting constraints. So you don't necessarily have to worry about making it in exactly the right place, because I'm going to fix that, right? So schematically, I want a rectangle down there. So then what I can do is I can make this, and I'm only drawing the left half, and you'll see why later. Although I'll tell you why, is because I'm going to rotate that rectangle around in order to make a disc later. So right now I only care about the left half. And so this is in blue. If you're new to Fusion 360, these blue lines here, oops, these hard to click on things sometimes. These blue lines here effectively mean that that this stuff is why is this not? Sorry. Okay, I'm not gonna try to edit that out. Me getting confused. I might have some selection filters. Yes, look at this. So if you ever find you're trying to click on something and it's not letting you click on the things you want to click on, it's possible that you have a selection filter enabled. So there we go. That's what I was trying to do, but it wouldn't let me click on that edge. Okay. So the blue stuff here means that this is not completely constrained. So these could be any place, right? I just drew this rectangle, and there's no reason why this rectangle couldn't be wider or couldn't be in a different position or so on and so forth. The only constraints here are these things, which if you hover over them or click on them or something, yeah, that's a vertical constraint, and this is a horizontal constraint. So that's saying that this line has to be vertical, this line has to be horizontal. Other than that, they can be anywhere. And they can, be any size. Okay, I'm babbling on. Let me just move to the next thing that I want to do. So the next thing I'm going to do is go up to my constraints, speaking of which, and I'm going to establish a few constraints that will lock this thing down. So the first one I'm going to do is a collinear constraint. So what I want to say is that this line, this part of this rectangle here, this line has to be lined up with this axis line, which happens to be the center, right? So if I click on collinear there and there, right, then what that does is it requires this line and this line to be collinear, right, lined up. And so I could no longer, if I try to move this, it won't let me move that anymore. I can still move the other ones because I haven't done any constraints on those. But so this is now basically in the middle. That's why I did that. Now, another thing we can do here is, what's the distance between the bottom of this lamp and the top of this rectangle? Well, I don't know. Let's make one. So we're going to press D for dimension, and I'm going to select the two things. Whoops, I already have that selected. Sorry. Dimension, and then I want the dimension between here and here. There we go. What should that be? I'll click there and type a number. I don't know. What looks reasonable? 1/2 inch? Yeah, seems okay. So 1/2 inch between the bottom of the bulb and the top of this part. And you can see that turned black now because that also, given that this is a fixed point and this is 1/2 inch below it, this line now has no option for where else it could be. So let's keep doing this. Right now we have an interesting one. How thick should this be? Well, the thickness of this really depends on the material we're using, right? So this rectangle is representing a piece of wood, and what I'd like to do there is I'd like to go up and actually create a parameter. So I'm going to go to Modify, Change Parameters, and I'll just create a user-defined parameter. I'm going to call it Material Thickness. Because when I have something like this that I might change later, this is basically making a variable so that I can change it later if I was wrong. So in this case, I'm going to make it 1/8 inch. And this is where you might come in and actually measure your material and find that it's different, and you could actually come back and change that parameter and your entire file would change to match. Now I just created a parameter, I didn't actually do the dimension, so let me do the dimension here. And now I could either click top to bottom, or I could just click on this piece here. It does the same thing. And I can say that I want this to be material thickness. Right, so instead of typing a number in there, I'm typing the name of that parameter that I created before. And so it's now using the value from material thickness, and if I went in and modified that, then it would modify this as well. Alrighty. Now we got one more thing, which is this here, this blue edge. How far out does this thing go? In this case, I don't know. It's a matter of it's kind of a design thing, right? So I'm going to dimension this, right? Distance between there and there, and I don't know how big it should be. How does 0.75 look? 3/4 of an inch. Seems reasonable. So that'll be what, 1.5 when it gets rotated all the way around. Okay. Now we've done the bottom, and now let's go and do the same thing for the top. So I'm going to follow the exact same process. I'll try to go a little bit faster here because we've already been through this once. So I'm going to draw out a rectangle. Again, it doesn't matter what size it is because I'm going to now make my changes to it. I'm going to add a collinear constraint, again, to the same thing. So I want that to be the axis that's lined up with the middle of this thing. I know that I want the distance between what's now the top of the light bulb and the bottom of my rectangle there to be something. Now in this case, I think I'm going to make it larger. So I made it only 1/2 inch on the bottom. I might go with a whole inch here, possibly. The reason is because if you look at this thing, see there's a big space on the top. Well, maybe it's not that big. Again, you'd have to, depending on what kind of fixture you get, you'd have to figure out what that space is going to be. But I'm imagining that the space on the top is a little bigger than the space on the bottom. So let's fix this here. And I put in 1, I think that's too much, so I'm going to change it to 0.75. And then this will be material thickness. So I'll put that in. And I'll just move where that is so it's a little bit easier to see. Hopefully starting to make sense now. And then the last thing is going to be how wide this is. And I think the top piece needs to be wider than the bottom piece. So maybe this is 1 inch. Okay. Now, there's one more thing I'm going to do, which hopefully will make a little bit of sense. If we go back to this, I don't know for sure because I can't see, but I'm imagining that there are notches in whatever these fins end up sticking into. You can clearly see there's some sort of a disc there. Now they might just be touching it and glued on that way, but I suspect for strength and stability, it's probably notched out. So there will be some overlap between the size of the disc and the size of the fins. And so I'm going to represent that by drawing a line. And if I do this here, you can see it's figured out that I want that line to always be 90 degrees. So perpendicular. And then similarly, I'm going to do the same thing on the bottom. Okay. And then now how far in does that go? It doesn't really matter, I suppose. I'm going to come up with some plausible amount that I want to put that in. Maybe 1/8 of an inch. And then same thing down here. Let's maybe make this 1/8 of an inch. And we might change that later if we find out that it's not working for our design. But that's going to be essentially the overlap between the disc and the fin. So now we can get to the fun part, which is drawing the fins. I'll use a spline for that, fit point spline. And this conceptually is pretty straightforward, right? There's going to be a spline that comes out, or curve, let's call it, instead of saying spline, a curve that comes out and then goes back, right? And that's, whoops, I hit escape instead of enter, which is something I have a tendency to do. I'm going for keyboard shortcuts. So let's do it again. Okay, so that's one, and then the other one is going to come out. Oops, got to reselect my spline tool. The other one's going to come out further, and then go back in over there. And I'm, as you can see, I'm a fan of doing things roughly. So that's the general idea. Now, of course, one of the things about these splines is there are a lot of control points and adjustments, and you can add more points and stuff. So we don't want this to sort of come out like at a sharp angle there, right? So if I select that, then what I can do is tweak it, right? So I can actually set my control point here so that there's kind of a smooth exit, right? So this continues out from the disk in a nice smooth way, and then I can do the same thing for this. So that we get kind of a less sharp situation. And then I'm going to go down and do the same thing down here. And this is the part where, if you have an eye for things, this is the part where it's less engineering and more art. I don't have an eye for art. I just know how to use the software. So you could take these points and you can do all kinds of things with them. So I'm not going to worry about it too much, because the idea here is the important thing, right? So you get conceptually, you can tweak these to your heart's content and make them look however you want them to look. And of course you can, like I said, you can go and you can insert another point. So one thing you might want to do is say, well, I don't like the exact way this looks, so by having more control points, you can, whoops, that's not what I wanted to do at all. Yeah, now I have too many control points. Delete that one, there we go. Yeah, so maybe you want this to be a little pointier, right? You could do something like that to make it a little pointier. Spend as much time on it as you feel it's worth. In my case, I think I've done enough. So you get the idea. I'm really tempted to keep adjusting this because it's hard to let go. Okay, it doesn't matter, right? It doesn't matter. Let's move on. Chris, move on. Okay, finish sketch. I'm going to click finish sketch over here, and now we'll be up to the next part. So there's our fin and the lamp. Sorry, the bulb. Now we're going to do a couple of things to make the actual 3D parts of this. What I should have done before I even started was created a new component. It's always a good idea when you're doing this stuff to not do things in the default component, but that was a mistake I made, so I'm going to create my new component now, and we will just call this lamp. Cool. And now what we can do, hopefully, is select, I'm going to select both this rectangle and this rectangle. I'm holding down the Shift key. Hopefully the software will let me do this. Sometimes it's a little finicky as to what you're clicking on. There are, well, I guess I could show a technique for that. I'm trying to zoom in to make this easier. There we go. So I've selected the whole rectangle that I want to use for the disc shape, and I'm going to go into my Create menu and select Revolve. So that's the idea, that I'm going to revolve this around. And then now it wants to know, I've selected the profile already. Now what axis do I want to revolve it around? Obviously this one. And there is our disc. Easy as that. And now I'm going to do the same thing. I can do it a slightly different way. Click Revolve up there. I haven't selected a profile yet, so let me go down to the bottom. Oh, by the way, worth knowing, when you do something like that, it tends to hide the sketch that you just used. I think there's a preference for that, so that's why this disappeared on me. But it didn't go anywhere, it just hid it. So I can select the profile, and then I can select the axis. And there we go, there's our bottom disk. Cool. And now what I want to do, because I like to keep things tidy, let's hit the home here to zoom back out. I have body 1 and body 2. I'm going to rename this to top disk, and I'm going to rename this to bottom disk. Cool. And now you might see, fairly obvious here, we have one more piece to make. And what I'm going to do is hide these for the moment to make it a little bit easier. And I want to select, just to show you, I'm selecting this, but also I'm selecting these little boxes here, because if you remember, there's overlap, right? This sticks in to, get close enough so that I can, there we go. This sticks into the disk. So I've selected the correct profile here, and this time I'm not going to revolve, because that would make a big circular thing. I'm going to do a press pull, and the idea here is you can just take a 2D thing and thicken it into a 3D thing. Now in this case, the thickness I want to make this is going to be material thickness. I already have a parameter for that. And here's an important part. When I make this, if I make it just go in one direction, then it's going to be kind of off-centered, right? Or if you think of it as like the center line is here, right, on the front, then if the center line is on the left side of this, and I'm just pulling it to the right, then it's going to be off center. Similarly, if I go to the left, it's going to be off center. What I really want to do, put this back to the correct thickness, is I want the direction to be symmetric. So I want it to go equally to the left and to the right. And the total amount, I don't want, material thickness is not half the length, because that makes it double size. I want material thickness to be the whole length, right? So it's going to go halfway to the left and halfway to the right, so that it makes a thing that is a total of material thickness thick. Hopefully, again, that makes some kind of sense. So I'm going to click OK. And now I have my, call this a rib fin. It's a fin. Okay, and we turn these back on. And this is the general idea. Starting to make sense. Now there are kind of two operations left in a sense. We need to make more copies of the fin, and then we need to notch out these disks. And we actually need to put a hole in the top. So first things first. Again, I'm going to remove, just hide the disks to avoid confusion. And I've already got this fin selected, and very easy in the software. That's what I love about this. I want to create a circular pattern. Boom. I want to create new bodies. So I've got this one body selected. I want to create new bodies, and I want to go around this axis. Look at that, it's already got 3 by default. That's not the correct number, right? So what I really want is 16. And that's it. So you can take a quick look at what it would do here. They all fit, just to make sure they fit in the bottom. Everything fits, so I'm just going to hit OK. Boom. Now I have all 16 of these fins. One thing is that this is looking all kind of plasticky, so I'm just going to, this is totally unimportant, but just for fun, I'm going to go into my physical material library and just grab, how about some cherry wood? So let me go and put that in, and I can just select all of these things, and I will drag and drop this cherry onto it, And there we go. Now this thing looks like it's made of wood. All right. So now we just have to notch out the top and the bottom. Because remember, here's a cool thing I can do. Group. I can create a new group and call this fins to keep things organized. Just drag those into there. So if I hide the fins, you can see they're currently interfering with the top and the bottom. What I want to do instead is I want to do what's called a combine. So I can go to modify combine. This is otherwise known as a boolean operation. So the target, I want to target this top disk, and the tool bodies I want to use are the fins. I don't think I can conveniently select them all, so I'm going to click the top one and then shift click the bottom one to select them all. And you can see the operation is cut. It kind of figured out what makes sense based on the fact that they overlap. And I want to click keep tools, otherwise it'll throw away the fins after it uses them to cut the top disk. So now if I hide these fins, you can see that that top disk is all notched out. Very easy. And I'm going to do exactly the same thing with the bottom one. Combine, selected my target body, I'm going to select my tool bodies. Can hit OK. And now I have notched out the bottom. So there's really only one thing left. If you really wanted to, we can create a hole. Let's hide everything except the top disk. Yeah, so you could go and you could make a hole in a couple of different ways, right? You could create a sketch on there, and then you could cut it out from the sketch. But there's a built-in hole tool. I'm not sure what will happen if how I can align this. Oh, there we go. It snaps. Okay. I was just worried that I couldn't center it, but it actually snaps. So easy peasy. Now this whole tool is kind of complicated because it's designed to make all kinds of countersinks and counter bores and things. And I find to make sure that I'm not making a weirdly shaped hole, I like to, first of all, let's zoom right in there. I like to ensure, can you see here how it's got a triangular dingus going on? I like to say that the extent of the hole is to the bottom of the piece. And so that way it ensures that the hole goes all the way through. And that's this section here. So I don't really care about the countersink because the countersink is below. See, there's a regular cylindrical part, and then there's a kind of cone shape. So the cylindrical part goes all the way through. So I don't really care. You could select flat, I guess, would be the other way to do that. Make sure that you're cutting the hole all the way through. Anyway, that's all done. Simple way to say, now we got a little ring with the notches in it. And so if we go back to showing everything, okay, activate the default component so that nothing's grayed out, hide the sketch, and there is our lamp. Now, how do we cut this out? That's an interesting question, and I will come back in part 2 to explain that. This isn't really a 2-part video. I just wanted to take a break. So I'm back, but hopefully you're still here. The question now is, how do we manufacture this, having done all this work? Now, clearly, all of the fins are identical. So what we really need to do this is we need a copy of the top piece, the bottom piece, and one of the fins, and then we could just duplicate that. So simple enough. In fact, let's just simplify our lives here, and I'll just hide. I think I can do that by pressing. No, I can't. I've forgotten the keyboard shortcut for hide, so do it this way. Okay, so we've hidden all but the original fin, as it were. Now what I like to do, and this is a part where, I don't know, I made this procedure up myself, so there may well be a better way to do it. I'm also going to hide this light bulb here. We don't need that anymore. So if anybody else knows a better way to do this, by all means, let me know. But what I like to do, and this is why I created a new component here. So I created this lamp component so that we could have, go back to the base here. I'm going to create another new component. It's going to be an empty component, and I'm going to call it, I don't know, cut, not gut, cut sheet. And this is kind of what I like to do, is create a component that's going to hold essentially copies of these things that are all laid out flat. You'll see what I'm talking about in a minute. So we've got three pieces here, right? We've got this fin, this top disk, and this bottom disk. I'm going to select those from the lamp component. I'm going to Command C copy. I'm going to go into here and I'm going to Command V paste. And now I can hide my lamp component. Forget about that for the moment. And now we're working entirely in cut sheet where we have copies of these three things. So looking at this from the edge on, clearly one of these is already sitting on the ground, and one of them is floating up in the air, and one of them is sideways. So we need to fix that. We want to lay them all on the ground. I'm going to show you the way I do it. Again, let's use the Align feature. So I can select Modify Align. I want to align it body. Now, what do I want to align to where? Well, I want to align the bottom of this, doesn't matter exactly where, but any place on the bottom, to this ground plane. So I have my origin displayed so I can see it's a little bit light to see there, but I'm clicking on this rectangle that represents the, I guess, the XY plane. There we go. And so what that has done now is that has put that flat on the ground. Now, unfortunately, it also moved the other, I think it moved the other two, did it? I'm not sure. Sometimes you can't tell what's going on. It can be a little bit tricky, to be honest, to do this part. This is something that I wish were a little bit easier. I wonder if there could possibly be some scripting that would make it easier. But what I tend to do is start looking at these things edge on. There's something not right. I will figure it out later, and then I'll be like, I wish I knew that. Yeah, I wish I knew what I was talking about. But anyway, so we also have to lay this one down. So I'm going to let's just try this align just that body. So I've selected that already, and I want to align that again to the ground. If I can pick up that, there we go. Now, this is where sometimes if you look at this edge on, you can see that it's actually underneath, because there are two possible ways to align that. So when I have that situation, I click flip so that it flips it so that it's actually sitting on top of the ground. So those two look okay. There's still something not quite right about this whole situation. Clearly there's this guy is underneath. I guess it was always underneath. I didn't acknowledge that earlier. So let's first, I don't think I can drag this. I think it drags the whole thing. There might be a way to adjust that. But the first thing I'm going to do is I'm going to move this one body, this ring, and I'm going to sort of free move it, slide it off to the side so that I can, basically it's not in my way. I could also have just hidden it. Why don't I just do that? Okay. So hopefully you can see here that this process is a learning process for everyone. And depending on the views can be a little bit hard, right? Because you're projecting 3D space onto a 2D computer monitor. But hopefully we can see from here that this bottom piece was actually below ground, which makes sense because the bulb was sitting up here and we put space between the bulb and this piece. So I need to align this. So I'm going to modify, align. I'm going to align the underside of this with my ground plane. And so now when I rotate this, yeah, hopefully the 3D is working well, and you can see that that is now aligned with the ground plane. So I'll turn the other two pieces on. Took a little bit longer because I was talking about it while I was doing it, but you know, the idea now, there we go. So now when I look at it from the front, you can see this straight line here, and everything is sitting on top of that line. So I've flattened these all out. They're all coplanar, which is the important part. And I could move them to be closer together or whatever, but you'll see why in kind of the next step that it doesn't even matter. So now that I've created this cut sheet, and again, this is just a copy. That's why I did that, so that my original lamp, if I unhide all the things that I hid, is still, my original lamp is still around in its own component, but I've created a copy here of the pieces that I want, and I've laid them out flat. So that allows me to take this into the manufacturing workspace. And this is where I will do my actual creation of the laser cut file. In manufacturing in Fusion, you have to create a setup, which is what defines the model and the stock, the piece of stock that you're manufacturing into your finished product. In this case, it's started out by creating this big box because it doesn't know what my model is. So the first thing I'm going to do is go down to click on model, and I'm going to select, I have to open all these guys in order to get to the one I want, the cut sheet. So the model is my whole cut sheet component. You can see it immediately reduces this sort of yellow greenish box here, represents the stock or the sheet that of material, a piece of material that you're going to be working out of. So the next thing I should do is, the first thing probably I should have selected the type of machine I'm going to be using. So there are here we go. In Fusion 360, there are samples of a lot of different machines. I tend to only use the ones. If you filter this down by cutting, you can see that they have a generic cutting machine, and that's good enough for my purposes. So if I select that, now we've got our operation type set to cutting. If that's not set to cutting, if it's milling or turning, or here's a nice pop-up that shows you the differences between all of them. We're not 3D printing, we're not using a lathe, we're not using a milling machine, we're using a cutting machine. Water jet laser or plasma, in this case a laser, right? So that's all set up the way I want. And now there are only a couple more things that are wrong here. The first thing is that if I look closely, you might see, I don't know if you can see this or not, but the stock is bigger than the actual object itself. So that's sort of an assumption. It's built into the software. That probably would be true if you were milling it out, but in this case I'm going to take a flat sheet that's exactly an 1/8 inch, and I'm going to end up with something that's an 1/8 inch. So I could go over to the stock tab, and rather than have relative size, see it's added an offset of 1 millimeter to the side and the top. I can say that the offset mode, no additional stock. So that'll shrink that box to be exactly the size of the that needs to be to accommodate the component. Okay, and then finally the origin point is wrong. It's in the middle. We want it to be in the corner here. And the axes are right, so that's X, Y, and Z. That all looks good to me. Okay, click OK. Have a sip of tea. And now our setup is good. So now we want to add an operation to this. So the only one that makes any sense here is going to be this 2D cutting. What tool are we going to use? I'm not going to go through the process of setting up tools, but I have already previously, if you follow the instructions for the Glowforge Colorific post-processor, it explains how to do this stuff. So I've created a medium draft board laser cutter tool here. Essentially, that's because this tool defines things like the kerf width. So I've experimented to get that right, and for different materials, the kerf might be different. So I'm going to select that tool. And now there are a bunch of things in here. It's a little fiddly to do this exactly right. We need to first of all tell it, okay, what are you actually cutting here? In this case, if I do a contour selection and I do select same plane faces, I can click on the top of any one of these things or the edge of any one of these things, and it will cut this out, but it'll also cut out everything else that's on the same plane, right? So if I click this one, It'll select not just the contour of this one, but also the contour of that one and the contour of that one, which is exactly what I want in this case. We don't have to do anything else on that section. Heights we can ignore entirely. It's not relevant to the laser cutter. Passes, same thing. Actually, no, there's one setting we have to change. So the sideways compensation has to be changed from in control to in computer. This is what allows it to calculate the kerf. It's a technicality of the way that the post-processor works. If you don't set that, it won't work correctly. So you have to know to go into there. And then I don't think I care about anything in the linking section here. So I'm going to click OK. And now it will generate my profile. So you can see, hopefully you can see there's a thin blue outline around these, which is correct. That's what it's planning to cut. We could simulate it if we wanted. It's kind of pointless. But you can see that. So all looks good. And so I'm then going to just click my post processor. And this is going to, again, I've already pre-installed the Glowforge Colorific post processor, which is the one you want to use if you're cool. And under properties, this check sideways compensation, that thing's important. If you have that on, that will double check that you've got the correct settings. Otherwise, I leave these at the defaults and I click OK. And it's going to ask me where to save this. I'm just going to put this in my temp folder because I'm kind of lazy. So I will call this thin lamp profile, just as a reminder that this came out of Fusion 360. And that's it. So I'm just going to save this as well. It's always a good idea to save occasionally. Okay, so now we have this SVG. Now technically I could upload that SVG to the Glowforge app and I could cut it, but it's only one fin. You could duplicate it, you could move it around, you could do all that stuff in the interface, but that's not what I want to do here. What I want to do here is actually try to create a full sheet of these things. Also, bit of a tip. The SVG that's produced here from this post processor, I don't trust it. I like to load it into Illustrator or Inkscape, take a look at it, and then resave it, just because it's got some interesting behaviors. I'm going to open Adobe Illustrator, since that's what I use. And I've created a new file here using my favorite Glowforge preset. So it's all good to go. And then I'm going to File, Place, and I'm going to choose this FinLamp profile file here that we just saved out of Fusion 360. And I'm going to just stick it anywhere here on my artboard. That's all fine. And because it comes in with some weird defaults, again, I would just prefer to set the stroke to 1 point and set the color to my sort of default Glowforge black. It doesn't really matter. None of those are going to affect the cut settings, but that's the way I like to do it. Now here's the fun part. I want to try to maximize the use of a full sheet of material, and I'm not going to do that by hand. Yeah, I certainly could just grab one of these and duplicate it, and then try to put another one on and line them up myself. But I'd like to use a program called DeepNest, which will do a bunch of kind of AI stuff to try to optimize the use of a sheet of material. And in order to do that, I need to export this SVG from Illustrator. And there's a couple of tips here. So number one, if you take the file that you just saved with the Glowforge, in fact, I'll show you. If I start up DeepNest and I import the file that came straight out of Fusion 360, let me show you what this looks like. This is not right at all. Notice that the hole that's supposed to be in the middle of this is really weirdly sort of star-shaped. And if you look closely, even the outside edge of this disc, it's like convex instead of concave, or vice versa. I'm not sure exactly what happened here. but Colorific does not seem to produce SVGs that Deep Nest is happy about. We're going to round trip it through Illustrator, which is one of the reasons I opened it in Illustrator in the first place. And then another tip here is don't save as for Deep Nest. Now, for the Glowforge, you're supposed to use save as. I've learned through experience that it's better to use the export function in Illustrator. It produces an SVG that is more compatible with Deep Nest in this case. And so I'm going to call this FinLamp1 fin. And now to check my settings here, I've got presentation attributes, all this stuff is the way I like it to be, so I will click OK. Basically everything comes in the wrong size if you use save as instead of export. So now that we got the right file, we'll go back to Deep Nest, we'll import the one I just exported, and you can see everything looks right. This is 1.5 inches, that's 2 inches, so it's all looking like it's supposed to look. Now we know that on the Glowforge, the largest, the cutting area is 11 by 19 and a half. So I'm going to create a rectangle here that's going to be 19.4 by 10.9. I want to make sure that I don't go outside those bounds. So the way Deep Nest works is that you give it one or more shapes that are the sheet, and it's going to try to fit the other items onto the sheet. And of course, we right now only have one of those, but I can tell Deep Nest right here that this particular piece, we're going to have 16 of those. So that's all configured the way I want, and I'm going to click Start Nest, and it's going to start running its algorithm. And you can watch it go. These particular kind of arc shapes don't tend to nest very well, so it will be a struggle to get all 18 of these on here, and probably will not be physically possible. But if you want to, see the best the machine can do, this is one way to do that. And this, you basically let this run as long as you want. This is an interesting program, and it allows you to try to fit a bunch of stuff onto a sheet of material. But that's basically all. So what have we done? We started with a picture of a kind of thing that we were interested in making. We went into Fusion 360. We produced a model of that thing using some really basic techniques and using a pre-existing 3D model that we got off of GrabCAD to give us a kind of scale and an ability to kind of picture what this thing might look like when it goes together. Then we turned that into a sheet for manufacturing. We went into the CAD part of Fusion 360 to produce the SVG output, brought that over into Illustrator, and then into Deep Nest, and we're now running this program to see if we can fit 18 copies on a sheet or whatever. So when we're done with this, essentially we would just export the SVG out of here, bring that into the Glowforge interface, and then cut it out and stick our lamp together. And there it is. I feel like I'm starting to waffle on at the end of the video, so I'm going to stop now. I hope this was useful or interesting for those who stuck it out, and if not, I hope you didn't waste your time and you just quit early and you're not even hearing me talk now. If you do like me making videos, I appreciate when people subscribe. In particular, the subscription numbers go up, and they help enable more features on YouTube, and I think they help more people see these videos, and certainly gives me motivation to do them, that I know people are watching. So that's about it, and I will see you next time. Bye-bye.